Today's tutorial is going to look at mole conversions. Now, just as we looked at our dimensional analysis, mole conversions for right now is only going to have one conversion factor of molar mass from a previous tutorial. The same way we're going to look at problem solving skills. Our given or our known goes first over 1. Our conversion factor is next, making sure that our given units cancel out, and our unknown or our answer is left over. So let's set up some skeletons for mole conversions. If we are given some number of moles, that's going to be our first over 1. What we need to cancel out next is moles per grams. Now from our molar mass tutorial, you'll notice that it's always a number of grams per 1 mole of whatever you're looking at, your element or compound. So our unknown answer is going to be grams in this. So our moles cancel out with moles and we're left with grams over here. Now if we reverse it, what if we were given grams first and then we had to determine the moles? So now our number of grams comes over here as our known per 1 times our conversion factor. What we're going to do to our initial conversion factor is flip it over. So we're not going to have grams on top, we're going to have the number of grams on the bottom. Note that the number always stays with grams per 1 mole of whatever you have. So now our grams cancel out and our unknown answer is going to be in our moles. Make sure that you do not forget your units throughout because we'll eventually be getting to 1, 2, and 3-step problems when we get to stoichiometry. Now let's try an example. How many moles are in 34.0 grams of H2O or water? So we're going to set up our given here, 34.0 grams over 1 of H2O. Now if we look back at the top, which skeleton do we want to use? We're going from grams to moles, so we're going to use our second one. So we're going to have the molar mass of H2O. Remember, when calculating molar mass, you're going to look at what you have. So we have 2 H's, 1 O, and we're going to have 1.01 here, and we're going to have 16 for our oxygen here. So when we add it up, we're going to have 18.02 grams per mole. So we're going to put 18.02 grams on the bottom per 1 mole of H2O. So I'm going to continue to write whatever compound it is too. Our grams of H2O, our grams of H2O cancel out, and we're going to multiply the top, so 34 times 1 is still 34, and multiply the bottom, 1 times 18.02. So now let's get our calculators out, and we're going to do 34 divided by 18.02, and we're going to get 1.8868 moles of H2O. Now looking at our answer, we're going to use the number of sig figs from our given. So we have 1, 2. Is this 0 significant? Yes, it is, because it's there for a reason, not just a placeholder. So we're going to have 3 sig figs, 1, 2, 3, and it's going to round up to 1.89 moles of H2O. Now let's try another example. How many grams are in 0.100 moles of CO2? Now it's the reverse. We're given moles and we want to find grams. So let's set up our known first, 0.100 moles of CO2 over 1. What's going to happen on our bottom is that moles have to cancel out and it's always 1 mole of whatever you have. So our grams of CO2 goes on the top. Now C is going to be equal to 12.01, and we have 2 times 16, which is 32. So when we add these up, we're going to get 44.01 as the molar mass of CO2. We're going to cancel out our moles of CO2. We're going to multiply the top and divide by the bottom. Luckily the bottom is just 1, so let's get out our calculators and let's do 0.100 times 44.01, and we're going to get 4.401 grams of CO2. Now what we want to do is do it to how many sig figs. These are rightmost zeros, this is the left, so this one does not count. So we have 1, 2, and 3 sig figs. We have 1, 2, and 3 sig figs. 1 does not round up, so it's 4.40 grams of CO2. Thank you for watching on Mole Conversions.